All right, we're chapter 1, section 4A. Remember, your quiz next Thursday is on 1.2A, which is just the linears. 1.2B, which is our rationals. It's going to be over this, solved by factoring, 1.4A. And we're also going to do completing the square, 1.4B. You're just stretching. I just did the quiz. It's 10 questions. 9 of them say solve. So you guys have to understand which method to use. You cannot use the quadratic formula yet, for those of you who know it. I know you learned it in Algebra 1, but we haven't, quote unquote, learned it yet, so you can't use the quadratic formula. But there is one question that's going to say solve by completing the square. That's what we're going to do Monday and Tuesday. So you have to do that one method, but the rest of them are just going to say solve. So you need to know if I solve by factoring, or if I solve by taking the square root, or if I solve by getting a common denominator, all that stuff. So again, I press upon you, practice, practice, practice. If you guys need to come see me this afternoon, feel free. I have to walk over and get my girls at 2:30, so I'll be back around 2:45. But you can come Monday morning, Monday afternoon, Tuesday morning, Tuesday afternoon, Wednesday morning, Wednesday afternoon. I am available. All right, so we're going to solve by factoring. I told you guys factoring is never, ever, ever, ever doing what? Going away. Never. How are we going to solve by factoring? Well, the first thing I want you guys to make sure that you do is get all the terms to one side. You are going to be given problems where there's terms on both sides. I want you to get everything to one side and set it equal to 0. Then we're going to factor the equation. Then you set each parenthesis that you have equal to 0 and solve. Okay? Everybody with me? We're going to factor by solving. Solve by factoring. Look. What do you notice about all 4 examples on this page? What's the exponent? 2. The exponent is 2. That's called a quadratic. The highest exponent, and you'll learn this as we go along, but the highest exponent you have in an equation tells you how many answers you should have. So for all of these on this page, how many answers should we have? 2. Okay, so just be aware of that. So when I go to solve this, solve by factoring. Well, think about this, guys. If I solve by factoring, what is this? The difference of squares. So I could rewrite this as what? X plus 1 and x minus 1 equals 0. Then you set each parenthesis equal to 0. And you solve. So x equals what? -1, and x equals what? +1. Some of you are like, can't I just move 1 to the other side and take the square root? Sure. The problem with that, though, is when you have like x squared minus 1 equals 0. Then you move 1 over, so you get x squared equals 1, and then you take the square root. What are some of us going to forget to do? Put it on top. No, well, possibly, but a lot of people are going to do that. Is that my answer? It's part of it, but is it my whole answer? No. What's my answer? Positive and negative. We're going to do solving by square roots in a little bit. So again, you can do that if you have x squared and no x term. But right now, let's just focus on just trying to factor, okay? So let's look at number 2. First thing we need to do is make sure everything is on the same side. Is it? Okay. So when we factor, guys, what's the first thing we look for? GCF. So I'm going to just take out a what? X. And I'm left with 3x plus 1. Perfect. Now what do I do with each piece? Whoa, terrible color choice. What do I do with each piece that I factored? Set it equal to 0. So I have x equals 0 and 3x plus 1 equals 0. Again, is it okay to have x equals 0 as an answer? Yeah, absolutely. So here I have x equals 0. What's the other one? X equals, what kind of 1/3? -1/3. Remember, you move the 1 over, becomes negative, and then divide by 3. Signs are super duper important because these x values that you're finding, x equals, these are where this graph, if you were to graph it, crosses the x-axis. So there's a huge difference between positive 1/3 and negative 1/3. Just be mindful of that. Yep. Yep, your highest exponent's 2, right? All right, perfect. So what do we do now? What's the first thing I need to do? Get equal to 0. Everything to one side. So I'm going to subtract x. So x squared minus x equals 0. Now, how do we factor this? Take out a GCF. What is my GCF? X, and I'm left with x minus 1. Perfect. Now we do what with each piece? Set it equal to 0. Awesome. So what are my 2x values? X equals 0 and x equals 1. Good job. The only thing new about this is instead of leaving it as x times x minus 1, like in its factored form, you're just solving. You set the piece equal to 0. Nothing else is new. All right, is everything on one side? Yes, guys? Okay, perfect. So we're going to factor. What are the factors of negative 8 that multiply to give me negative 8 but add to give me 2? What kind of 4, what kind of 2? Plus 4 and minus 2. Perfect. Now what do I do with each parenthesis? Set it equal to 0. I know I keep repeating myself. You guys are like, oh my gosh, you keep saying the same thing over and over and over again. Because when you guys are on a test or on a quiz, I want you to sit and think, what would Miss Meadows say? Try to hear my voice in your head. Not like in a nightmare, like in a good way. So what are my two answers? X equals negative 4 and x equals 2. Perfect. Questions? All right, scooting along. Same thing, we're going to solve by factoring. I know I'm going to factor because it's x squared. So what do? Everything on one side? Perfect. So let's go a times c. Factors of negative 30. Okay. So negative 30. I have negative 6, negative 5. Which one? Negative 6, positive 5, negative 6. Okay, good. Negative 6, positive 5. Make sure your signs are right. I'll do this one by grouping. So I'm going to write 2x squared minus 6x plus 5x minus 15 equals 0. You guys want to write it out the other way that I showed you like this? X minus 6, x plus 5. And then what do we do with the a term? Divide by 2. Can you see that? Yeah. Either way, you'll get the same answer. This becomes x minus 3, and this becomes 2x plus 5, right? You guys with me? Okay. So up here, if you guys do it the grouping way, which is how some of you like to do it, which is fine, group the first two, group the second two. What can I take out of 2x squared and a negative 6x? 2x, okay. And I'm left with what? X minus 3, okay. What can I take out of 5x and negative 15? 5. Positive, right? So I'm left with x minus 3. So my two parentheses become x minus 3 and 2x, that's not x, plus 5. Set equal to 0. That's what we got down there, right? Same thing. So now we solve, guys. I have x minus 3 equals 0. 2x plus 5 equals 0. So on the left-hand side, x equals what? 3. Perfect. On the right-hand side, I'm going to subtract 5 and divide by 2. So x equals? Negative 5 over 2. Good. Very good. Guys doing great. All right, how is 6 a teeny bit different? There's something on the other side. What's the first thing you guys absolutely have to do? Everything to one side, set your equation equal to 0. You have to do that first. So I'm going to go ahead and subtract 3 from both sides. So I have 2x squared plus 9x plus what? Plus 4 equals 0. So now a times c. What are the factors of 8 that multiply to give me 8 but add to give me a positive 9? So x plus 1, x plus 8. All right, my a term is not 1, so what do I do with that a term? Divide by 2. So over here I have 2x plus 1, and over here I have x plus 4, all equal to 0. Now what do I do with each little piece? Set it equal to 0. So 2x plus 1 equals 0, x plus 4 equals 0. So on the left-hand side, I'm going to subtract 1 and divide by 2. So x equals negative 1/2, good. And on the right-hand side, I'm going to subtract 4, so x equals negative 4.
Wait, I put negative 0.5. Is that also correct? Or does that have to be like in a fraction?
Let's leave it in fraction form. Mathematically, that's correct, but yeah, just go ahead and leave it as a fraction. Okay, I'm going to go down to 7. I know I skipped. I'm going to go down to 7 and then over to 8. I was going to go up and down, and then I went left to right. I initially in my mind said I was going to do it. How do I begin this one? Move what? Move the 3x. Get everything to one side, guys. Every single time we're doing the same thing. So I have 6x squared minus 3x equals 0. And now we're going to factor. What's the first thing you look for when factoring? GCF. What is your GCF between 6x squared and negative 3x? 2x. Perfect. Take out that 2x, and what are we left with? 3x. I'm sorry. I thought you said 2. So 3x. Okay. What are we left with? 2x minus 1 equals 0. Do you guys see why it was so important when we were factoring and I said, don't forget the GCF? When you just put it under each term but then didn't put it in your answer. The reason why is because that is actually a solution. That GCF that you pull out is a solution to this equation. That's why you can't just leave it out in thin air. It goes with this. So I set each piece equal to 0. 2x minus 1 equals 0. Divide both sides on the left-hand side by 0. What do you get? I mean, by 3. What do you get? 0. On the right-hand side, we're going to add 1. Divide by 2. So x equals. Perfect. You guys doing good. Anyone have any questions? We okay? All right, number 8. Same kind of problem. Before I do anything, what do I have to have my setup look like? Everything needs to be on one side. Your equation needs to be equal to 0. So I'm going to subtract 2x from both sides. I have 8x squared minus 2x equals 0. What do I take out? Perfect. Take out your 2x. And you're left with 4x minus 1. Perfect. And then what do I do with each piece? Set it equal to 0. Is this becoming redundant? We're doing the same thing over and over and over and over again? That's good. You guys should be able to see a quadratic and think, or x squared and think, okay, solve by factoring. What do I do? Move everything to one side. Set equal to 0. Then factor, GCF, trinomial, perfect squares, whatever it is, and then set each piece equal to 0. So I'm going to divide by 2. So x equals 0. Here I'm going to add 1. So 4x equals 1 and divide by 4, right? So x equals 1/4. Perfect. Great job. Great job. Great job. Great job. Okay, a few more of this. I'm going to go to a different look. All right, in a problem like this, we want everything to one side. You are more than welcome to move the x squared to the right. The only thing that happens when you do that is x squared becomes what? Negative. So if I were you, I would move everything to the left. I'm going to add 6x and add 9. So I have x squared plus 6x plus 9 equals 0. What are the factors of 6 that multiply to give me 6, but add factors of 9? That multiply to give me 9, but add to give me 6. 3 and 3. Good. X plus 3, x plus 3. So you have two solutions here, but they happen to be the same. You guys see that? So your answer is x equals what? -3. Do you have to write it twice? No. That's called multiplicity. You guys will learn that in pre-cal. When you have the same answer a repeated number of times, it's called multiplicity. But you do, if you want to write x equals -3, x equals -3, totally fine. But if you show your work that you split it into x plus 3, x plus 3, and then just write your solution one time, that's fine. All right, this is a bigger problem here. We can go ahead, everything's set equal to 0, 3 terms, no GCF. You can go ahead and go a times c, right? 4 times 9 is 36. But let's just check to see if this is a perfect square trinomial. What times what would give me 4x squared? 2x and 2x. What times what would give me a positive 9? 3 and 3. All right, how do you know something's a perfect square trinomial? You take the first thing, 2x, You multiply it by the second thing, which is 3, and then you multiply it by what number? 2. What is 2x times 3 times 2? 12x. Is that what this is right here? So then we discovered this is a perfect square trinomial. So what is your perfect square trinomial? What's the binomial? 2x plus 3, and how many of them do you have? 2. Squared. If you want to write them both out, you're more than welcome to. You don't have to. So again, we have 2 answers. They just both happen to be the same. So I would say 2x plus 3 equals 0. Subtract 3. 2x equals negative 3. Divide both sides by 2, and x equals negative 3 over 2. How many negative 3 over 2's do you have? 2. If you wanted to multiply a times c, you'd get 36. What are the factors of 36 that multiply to give you 36 and add to give you 12? It'd be 6 and 6. And then factor by grouping or by my little way. Have we already had this problem? We had something close. This is checking to see if you're paying attention to your signs. Everything's on one side, right? Set equal to 0. No GCF. So what are the factors of negative 8 that multiply to give me negative 8 but add to give me a negative 2? X minus 4, x plus 2. Perfect. So my 2x values are 4 and negative 2. Guys, what happens when you go from the parenthesis to x equals? What happens to the sign? It changes. It flips. If you have a minus inside the parenthesis, when you solve, it's going to become positive. If you have a positive inside the parenthesis, when you solve, it's going to become negative. Because you're setting it equal to 0 and moving to the other side of the equal sign. Just notice that. Little things to make sure you don't make silly mistakes. All right, look here. A couple ways you can do this. You can move everything to the right if you want, or you could just move the 3 over, which is what I'm going to do. So negative x squared plus 4x minus 3 equals 0. Am I going to factor just like this? Why not? The a term's negative. Go ahead and factor out that negative 1, guys. It makes your life easier. So x squared minus 4x plus 3 equals 0.
We could just move to the other side.
Yeah, if you move it to the other side, you got to make sure you get your signs right. Right, so if you moved, if you kept 3 where it was, and you moved negative x squared over, it becomes what? Positive? Positive 4 becomes negative. So that's fine. You can do it that way too. So when we go ahead and solve, watch what happens here, guys. What are the factors of 3 that multiply to give me a positive 3 but add to give me a negative 4? Negative 1 and negative 3. Okay. Now what do we do with each piece that we factored? We set it equal to what? 0. Negative 1 equals 0. Is that ever true? No, so you don't have to worry about it. If you factor out just a number, say the GCF was 2, and you factored out the 2, that is not x equals 0. If there's an x with it, if there's a variable, then yes, you'll have x equals 0. If you have just a constant, it goes away because that was the GCF. So here you have x equals what? 1 and 3. Perfect. And again, the beauty with all these problems, what can you do with your x value? Plug it in. All right, then we get to something like 13, and you're like, oh, Mrs. Meadows, we were on a roll, and then you do this. How would I approach this problem? Find a common denominator. Okay. What could you multiply this entire equation by? What is that going to do? If I multiply the whole thing by 8, what is that going to do? It's going to get rid of our denominator. Perfect. If you would like to go ahead and factor 1/8, feel free. What times what is going to, it would be 2 root 2 on both sides. I don't think that's a good idea. Get rid of the denominator. So multiply the entire equation by 8. So think about it. It's got to be both sides. We're set equal to 0, so no big deal, but always both sides. So when I multiply here, what's 8 times 1? 8 divided by 8 is, so I have x squared. So then I say 8 times negative 1x is minus 8x. And then I have 8 times negative 16. Some of you are like, oh my, are you serious? Yes, guys, write it down. What's 16 times 8? Good. Negative 128 equals 0. Now, can we factor this? Yes. Do you know right off the top of your head all the factors of 128? No. But probably think you're trying to get a negative 8 in the middle. So it's probably not going to be 1 and 128, right? The factors will probably be a little closer to each other. So go ahead, play around with some numbers. Oh, look at you. What kind of 16? What kind of 8? Negative 16, positive 8. Good, because negative 16 times positive 8 is negative 128. Good. Huh?
They gave us the factors because we were distributing it.
Correct. See? Sophia, you saw it. That's good. Good thinking. So negative 16 plus 8 is negative 8. So when I set each piece equal to 0, what are my x values? Positive 16 and negative 8. Good. How do we feel in terms of today's lesson? Yesterday we felt okay, right? A little practice. How do we feel today? This is probably a little better because we've been factoring for quite some time. Because factoring is never going where? Never. You're gonna get to where factoring is fun. Quit looking at me side-eyed. All right, now we're gonna solve equations by square rooting. And you're gonna say, when am I supposed to do this? Okay. Again, practice. Practice, practice, practice to understand in each situation what you do. And we're going to practice a lot next week. I'll give you some extra practice over the weekend if you want it. I'll post it. But when you solve equations by square rooting, you want to get the squared term to one side. And guys, please remember this. Please, please, please. This is so important. When you square root both sides, when you physically put the square root sign on, what has to go in front of your answer? Plus and minus. Because think about it, it's x squared. So how many answers are we going to have? 2. It's going to be the positive and the negative. These are places on a graph where this particular function crosses. So if it's plus or minus 2, it's positive 2, which is to the right of 0, negative 2, which is to the left. So just keep that in mind. When you guys tell me, oh, come on, it's easy. All right, so now you're thinking, okay, how do I know how to solve by factoring? Well, guys, think about it. If you moved 15 over here, x squared, don't write this down, it's okay, minus 15 equals 0. Is there anything you can do with that? No, you can't factor that. That doesn't factor pretty. So that's when you say, oh, okay, wait, that one's not going to work. So I should just do what to both sides? Take the square root. Take the square root. Immediately when I take the square root, I put an x and I put a what? Plus or minus. Good. And my answer is the square root of 15. And then we have to ask ourselves, okay, wait, can I break that down? Is there a perfect or non-perfect square inside of 15? No. So we're good. There's my 2 answers. It's positive root 15, negative root 15. Again, here, I don't have a middle term. I don't have an x that I have to worry about. So you could just take the square root of both sides. You could have done this on the first example we did when it was x squared equals 1. I showed you that. Whenever you have just x squared and a number, you can just square root both sides. So let's go ahead and do that. Take the square root. So I have x equals, what goes in front of my answer? Plus or minus, and I have 48. Is there a perfect square hidden inside 48? Mm-hmm. What is it? Okay, you could do 12 and 4. 16 and 3. Both ways will work. Look, if you do 12 and 4, watch. I want you guys to see. You don't always have to get the biggest one, just makes it easier. If you do 12 and 4, then you're left with the square root of 4 is what? 2? So 2 root 12. Is there still a perfect square stuck inside of 12? Yes. So you would have to go again and say 4 and 3, right? So take that square root out. 2 times 2 is 4, square root of 3. If you did notice that, oh, wait, there's a 16 in there, you just made your life a little easier. But you can still arrive at the same answer if you just break it down to a smaller perfect and non-perfect square. You just got to keep going. So the perfect square in 16 is 4, so this becomes 4 square root of 3. Same answer, guys. The right-hand side just took a little bit of a longer root. But still correct. Okay, here's where these get a little different. And you'll notice here, oh, okay, this makes sense why I would take the square root of both sides. So what could you do here? What would be the long way around this? Could I write out 4x plus 1 times 4x plus 1, FOIL it, and then move the 20 over and factor? You absolutely could do that. Is that the quickest way to do this? No. If you have a binomial squared set equal to a number, you can just take the square root of both sides. You can take the square root here, and you can take the square root here. Because what happens when you take the square root of something squared? It cancels. Those are inverses of each other. So I have 4x plus 1 equals the square root of 20. Some of you are like, wait, 20 breaks down. I know it does. Let's just not do it yet. We'll do it at the very end. I'm trying to solve. I want to get x all by itself. So what do? If I want to get x all by itself, I have to subtract the 1, okay? So watch, I have 4x equals, I'm going to put negative 1, then I have my plus minus root 20. And then what's my last step? I'm going to divide by 4. So x equals negative 1 plus or minus the square root of 20 over 4. Now, what this is showing you guys is if initially you were like, okay, I have 4x plus 1 times 4x plus 1, and then I FOIL it out, and then I subtract 20, is this a nice, pretty set of two factors that you could just put into two binomials? No. That's why this is the way to go. Now, you got to look at this and say, is this simplified? Is this as small as I can make it? No, because 20 breaks down to what? 4 times 5. What is the square root of 4? 2. So your answer is x equals negative 1 plus or minus 2 square root of 5 over 4. And you leave it just like that. You can put the negative 1 at the back. Just make sure it's behind the 20 and it doesn't sneak up underneath the square root. I always just put it in the front. You can put it there. Yes, sir. Okay, now, that's a good question. I want you guys to fully simplify if possible, but you don't have to if only one term simplifies. You're fine here. If this was a 2, then yes, I'd want you to simplify. If you did want to go ahead and simplify this, the way that you would do it correctly would be x equals, remember these are two terms, they're over the same denominator, so it would be negative 1 over 4 plus or minus square root of 5 over what? 2. That would be fully simplified. You can't just cross off the 4 and the 2. You have to separate them and then simplify. So I'm good with right here, just so you don't make a mistake.
Are we going to have to do like the second part?
No. I mean, maybe if, if all of them were divisible, but not right now, no. All right. What about this one? Can I factor this? Is this the difference of squares? No, so I'm going to go ahead and add 43 to both sides and get x squared equals 43. And then do what? Take the square root. When I put the house on, what goes in front of my answer? Plus or minus. Is there a nice, pretty, perfect square stuck inside of 43? Yes or no? Nope. Keep moving. You guys are doing great. We're almost done. All right. What do you think I should do first here? Divide, okay. What could I do? Could I move the 36 over? I could. I get 9x squared minus 36, and that's the difference of what? Squares, okay. What I'm trying to show you is when you have your quiz, other than the completing the square, it's going to say solve. So if you see, oh, if I move the 36 over, this will give me 9x squared minus 36 equals 0, and then I can factor that, fine. Some of your brains work that way. Some of you said, wait a second, should we divide? Absolutely, go ahead and divide. X squared equals, does that divide evenly? Does it? 36 divided by 9 is? Okay. Now what? take the, okay, so x equals plus or minus 2. All right, let's go. What about here? Can I move 37 over and it becomes the difference of squares? No. Okay, so let's just go ahead and divide. Let's get x squared by itself. So I'm going to divide. Guys, before you try and say 37 divided by 25 doesn't work pretty, of course it doesn't. So just leave it for a second because we're not done solving. What can I do now? Take the square root. Okay, so I took the square root. I put the house, we'll say, the square root sign on top, so it's plus or minus. Now, underneath the square root is 37 and 25. Is there a square root or a perfect square inside of 37? No. So it's just the square root of 37. But can you simplify the square root of 25? Is what? Perfect. If there was a square root in the denominator, can you leave it? No. You guys, so many of you on your test got half credit off because you left a radical in the denominator where it said to simplify. Yeah.
So I just, do we have to divide by 25? Because I just went straight to the radical part, and I got 5x equals plus or minus 37. Is that wrong?
Yeah, you have to isolate, before you take the square root, you have to isolate the x squared. Okay, again, what can we do here? A couple things. We could take the square root, exactly. What else could you do? Write out x minus 5 2 times, FOIL it out, move the 25 over, see if it factors. Probably not the quickest way. May not always work, but what can I do right now? I could just take the square root of both sides. So I have x minus 5 because the square roots cancel out. And then what do I have on the right-hand side, guys? What kind of 5? I have plus or minus 5. That is not a simplified answer. When we solve this, that is not going to be a simplified answer because to get x by itself, you're going to add 5, right? Everybody see that? So you actually have two problems here. You have positive 5 plus 5, and then you have negative 5 plus 5. You have two answers, just like the other ones where you had plus or minus. You just couldn't combine anything because one was a radical and all that stuff. But here you can. What's 5 plus 5? 10. What's negative 5 plus 5? 0. There's your two x's. So simplify everywhere you can. Okay. What's the quickest way to solve this one? Take the square root. Perfect. So I have x plus 9 equals plus or minus the square root of what? 24. All right, don't do anything yet. I'm going to go ahead and subtract the 9. Harper just asked, can you write the minus 9 at the end? You can. Just make sure, guys, that it doesn't sneak up underneath the radical. I just like to write it in the front. So I have negative 9 plus or minus the square root of 24. Can you combine those? Can you say negative 9 plus square root of 24? No, so just leave it like that. But can you simplify 24? Yep, this is 4 and 6. So this becomes 2 root 6. So you have x equals negative 9 plus or minus 2 square root of 6. Some of you are going to say, oh, do we have to simplify? Yes, you do, guys. That's part of algebra. If you don't, you're going to get points off. So just get in the habit of doing it. Two more. What do I do to both sides? Take the square root. Perfect. So 4x plus 7 equals plus or minus the square root of 44. If you want to go ahead and simplify, now you can. I like to wait till the very end. So I want to get x by itself. So I'm going to do two things. What's the first thing I'm going to do? Subtract 7. So 4x equals negative 7 plus or minus root 44. And then what? Divide by 4. So x equals negative 7 plus or minus root 44 over 4. You get this far, that's pretty good. It's not full credit though. What do I have to do with root 44? Yep, what is it? Perfect, 2 square roots of 11. So it's x equals negative 7 plus or minus 2 square root of 11 over 4. Do you have to simplify further? No. If both numbers, the -7 and the 2 root 11, were divisible by the denominator, we'd want you to simplify more. But they're both not, so you can leave it. If you choose to, you have to separate. So it'd be -7 over 4 plus or minus root 11 over 2. All right, those things are both the same, but you can't just cross off the 2 and make the 4 a 2 on the bottom. You cannot do that. Because remember, these are together. All right, last one, then I'll give you your test back. What in the world? Okay, guys, when you come to this problem, all right, we talked about when you have a binomial squared, you just immediately or automatically take the square root. But in this case, that doesn't work. Watch what happens if we do that. If we just take the square root of both sides, we get x plus 5 equals x plus 4. Subtract 4 from both sides, subtract x from both sides, and this will cancel out, and you get 0 equals 1. And so then you naturally would say no solution. But you actually mathematically can't solve this problem by just taking the square root. Because think about it, we put a square root on, we get a plus or minus. So once we take the square root here, we're saying my answer is going to be plus or minus a number, which in this case, there is only one answer. There's not two, so that's why we can't do that. Whenever you guys come to a problem where you have both sides squared, both of your binomials are squared on both sides, you actually have to FOIL it out. This is one of those special cases where you actually have to go through, FOIL it out, and then find your answer. So let's go ahead and do that. I'm trying to erase it. It's kind of annoying. Sorry. Okay, so when we FOIL this out, on the left-hand side, we're going to have x plus 5 times x plus 5. On the right-hand side, we're going to have x plus 4 and x plus 4. X plus 4. So we're going to multiply. X times x is x squared. 5x and 5x is going to give me 10x. And 5 times 5 is 25. On the right, we have x squared. 4x and 4x is going to give us 8x. And 4 times 4 is going to give us 16. So now when we go to solve, we're going to subtract x squared from both sides. They'll both cancel. I'm going to move 8x to this side, and I'm going to move 25 to the other side. And I get 10x minus 8x is 2x equals -9. And then we divide both sides by 2, and we actually discover that there is an answer here. It's x equals -9 over 2. It's not plus or minus. There's only one answer that will satisfy this equation. So whenever you start off, guys, and you can plug it back in to verify that it's correct. Thank you to Chase Chris Weiser. But if you ever start off with a binomial on the left side and a binomial on the right side that is both squared, you can't just automatically take the square root because there is an answer hidden in there. You have to FOIL it out, solve, and what will happen is the x squareds are going to cancel out, so then it negates the plus or minus. You just have one singular answer of x equals.